define a vector space with the following operations. Two operations, one for addition and one for scalar multiplication, as we know it, is the vector space of, well, is it a vector space if you take the set of all positive reals with this addition and that scalar multiplication? The first thing I always like to do before I try to solve or answer a question like this one, I like to familiarize myself with the vector space. So what does it mean to have this? First off, what are the vectors in my proposed vector space? Well, they are vectors from R plus, because my R plus is my proposed vector space. Then if I look at V1 plus V2 with the tilde, I'm looking at V1 times V2. Let's choose two numbers. I don't know. I'll choose 7. You choose another number. Did you choose a number? Okay, good, because I can't hear you. That's very stupid. Why would you do that? I don't know. Whatever. So I'll choose another number anyway. So 7 plus 3. 7 plus 3 in this very specific addition is actually 7 times 3. They lied to you when they said the answer was 10. You can very confidently say this now. Or, if somebody tells you, 1 plus 1, 1 plus 1 is 2, right? It's not. It's 1. In this vector space. So you can talk to people about this. When they tell you what's 1 plus 1, you should always ask them in what vector space. Because if it's the vector space of positive reals is where this very specific addition operation is defined, then the answer is 1. And the answer can actually be anything. So you just have to set the right framework. Enough with the with the get to know each other. I think we already know now how this vector space is like. This is simple. This is just standard scalar multiplication. So you don't need to worry too much about it. But let's see what I have prepared for you here. That is a vector space checklist. Prepared a very nice checklist here for vector spaces. Let's also note, before we proceed any further, that the scalings are coming from the real numbers. That is just something that's extra. Okay, addition and scalar multiplication are commutative and associative. Yes. This is commutative. 7 times 3 is equal to 3 times 7. Scaling is also commutative and associative. So I don't need to worry too much about this. Usually this is number 0 because nobody actually checks it. Okay, but then the next one says V is closed under addition and scalar multiplication. What this means effectively that if I take, if I add two vectors to each other, I should get something in the vector space. If I add two vectors which are in the vector space, I should get something that's in the vector space. So this is what it means. Scalar multiplication means the exact same thing. So if I have C and I multiply it by some V1, I should remain in my V. Let's see if this works. Probably you're looking at the length of the video. I don't expect it to be too long, and you'll be like, okay, probably it will fail now because there's no way he goes on until the third one. And you're probably right. This is the one that will fail. And but Can you try to find out how it will fail? This is a question for you. Let's see. So if I choose two arbitrary vectors here, I choose two vectors in R positive. So this is a vector that's greater than 0. It's in R positive. This is a vector that's in R positive. Now let me expand on this. So this is really, this is not, this is more. So this is really just multiplication. And remember that your vector space is R positive. A number is an R positive if it is positive. So what you're saying is two numbers which are positive give a positive number when they are multiplied. And this is 100% correct. So we don't have any worries regarding the first one. And then you're probably thinking, okay, there's a problem with the second one. And yes, there is. And here's what's the problem. V1 is greater than 0. V is of course our vector space, which is R positive. It needs to be greater than 0. Then if I want this to be a true statement, then I must restrict my C to be greater than 0. And now I ask you the question, is this even possible? And so I put this question mark like this. Is this possible? Maybe try to pause the video and think about it. The reality here is that this constant is in the real numbers, which means that this constant can get very negative. It can get as negative as it could get. Like very negative. We don't like negativity, but this is just the reality of it. So it is not guaranteed that this C will always be greater than 0. And if it is not always going to be greater than 0, then this is not going to always hold for all scalars. For example, if I take, well, I don't want to say as an example, maybe I'll say as a non-example. And the non-example is, if I take choose any negative number, your favorite negative number, I don't know, -5 times V1. This will give me -5, which is not in R positive. Despite this being in R, and despite that V1 being, why did I write -5? It's not -5. Let's say I choose V1 to be just -5 V1, I guess. And V1 is greater than 0 because it's an R positive. Then what effectively happens here is that, what effectively happens is this V1 is greater than 0 and this is minus. So this will always be a negative number. And because it will always be a negative number, it can never be in R positive. And that's really the caveat. I'm not sure if I should tick this or not, because if I write an X, it seems like it is true, but it is not true. So perhaps I should maybe draw a line and say that this is not a vector space. So the answer is big no for this vector space. Do better.